The Contemporary Physics Education Project, CPEP, does a fantastic job of making physics more accessible and comprehensible. The posters are great for any audience. I think they could be beneficial in a classroom setting or for personal use by anyone interested in expanding their knowledge. Not only are the posters visually engaging and intriguing, but they also explain difficult concepts without the use of too much jargon or textbook-style language. They are a great entry point for all, and the additional resources listed on CPEP's website help clarify and further the understanding of these topics. The fundamental particle and interactions chart is impressive in its ability to clearly explain difficult material. Through the use of excellent illustrations that depict the characteristics of these particles and the brief text explanations and definitions of terms, one can really begin to understand the behavior and properties of these particles and their interactions. Like some of the other topics that the charts cover, I had fairly little background knowledge on the interactions of the subatomic world. Reading this chart and utilizing the student activities and resources provided on CPEP's website, I was able to strengthen my knowledge in the subfields of physics. Particle physics discusses the subatomic world, which is composed of particles smaller than an atom. The standard model of particle physics is scientists' best theory to describe the fundamental composition of ordinary matter in the universe. It explains how leptons, which include electrons and neutrinos, and quarks, which make up protons and neutrons, are the building blocks of all matter. The model also explains the interactions between these particles and the way in which force-carrying particles, which can be categorized into bosons, influence the leptons and quarks. There are four fundamental types of forces responsible for the properties of interactions going from weakest strength to greatest strength: the gravitational force, the weak force, the electromagnetic force, and the strong force. The gravitational force is not explained by the standard model. However, the other three forces all result from the transfer of those earlier mentioned force-carrying particles, bosons. The weak force is carried by the W and Z bosons and is only effective over a short range. The strong force, which as the name may indicate is the strongest of the four fundamental interactions, and is carried by the gluon and binds atomic nuclei together to stabilize them. Probably the second most known interaction to many, the electromagnetic force is carried by the photon and also involves the interaction of magnetic and electric fields. A crucial component of the standard model, the Higgs boson, is a particle of the Higgs field, which is an energy field that gives mass to some fundamental particles that travel through it. While the standard model does an excellent job of explaining some of the elementary particles and their interaction, it does have its limitations. There are many unsolved problems and important questions that arise with the new discoveries that the model does not answer. While we understand some of what the Higgs boson does, we don't know why it gives mass to some particles and not to others. We are also left questioning why the universe is still accelerating, what happened to the antimatter after the Big Bang occurred, and we are still left astray when understanding what dark matter really is. There will always be unsolved mysteries in physics, and sometimes the reason behind a certain phenomena will never be known. However, by continuing to learn, research, and discover more about the universe, particles and their interactions, and the physics behind how the world works, we are one step closer to answering more of these questions.